Hello everyone and welcome to Methods 3-4. Today we are starting nice and easy with some linear functions. So we are reviewing linear functions and their properties. What you need to be able to do is find the gradient of a linear function, find the x and y intercepts of a linear function, sketch a line, find the gradient using the tan inverse rule, and find the distance and midpoint of 2 points. So we'll start off with the linear polynomial function. What is it? Well, basically it's a straight line, and the key identifying feature is the fact that it has a constant gradient. So that means to get from one point to the next, the rise compared to the run is always the same. So it always has a constant gradient. The easiest formula to use is y2 minus y1 over x2 minus x1. So the difference in the y gives you the rise, the difference in the run, in the x's gives you the run. And this rise over run, because it applies to every single point, means that we have a constant gradient. Some special identifying features of types of lines. If two lines have the same gradient, which means their rise and run is the same, they are going to end up being parallel because the rate of change is going to be the exact same. Also, if you multiply two gradients and it equals -1, it means that the lines are perpendicular. So a perpendicular line is a line that crosses at 90 degrees. Another important formula you need to know is -1 on m is equal to n. Essentially, it's the same formula, just rearranged. And I'm using the letters m for the original and n for the perpendicular because another word for perpendicular is a normal line. So the perpendicular gradient is equal to -1 on the original gradient. The equation of a straight line can be expressed in a couple of forms. The most common form is y equals mx plus c. That is the form that I'm going to use a lot in my examples. Of course, you can use this form as well to be able to find that equation. I just find that it has a lot more working out involved, but of course, whatever works for you is totally fine. So another really important feature is the angle of a straight line. So basically, there's a relationship between the gradient and the angle that the line makes with the positive direction of the x-axis. So generally, what we have is a line from the positive direction of the x-axis upwards that will give us the angle. So the gradient of that line will provide me with this angle. There is something interesting that happens though if the gradient is negative, it actually ends up being over here. So for example, if the gradient of this line is -1, we actually end up, if we put that into our calculator, we get theta equals -45. That of course is the same as this angle, but if we're interested in finding this angle, as this is a straight line, all we simply need to do is just go 180 minus the 45, and that will give me the angle over here. So that theta, if it's a positive, will be the acute angle. If it's a negative, it'll be, again, the acute angle, but it's beneath the x-axis. It'll be a negative, so all you have to do is 180 minus that angle, and it'll give you this part here. So let's get straight into examples. Find the equation of, in the form ax plus by plus c equals 0 for this line. So it passes through the point 2, 3. It's parallel to the equation, to the line with the equation of that. Now, when we get in a question like this, one of the first things that I would do is go ahead and label the different and most important parts that are part of this question. So first thing is we've got an equation here. And what it wants me to do is it wants me to find the parallel equation to it. I know that it passes through the points 2 and 3, and I also know that they want me to give it in this particular form. And that's really important to understand how it is that we need to respond so that we make sure we get our full marks. So where do we start? Well, we know that parallel lines means that the two gradients are going to be equal to each other. So in order for me to be able to find the second gradient, the parallel one, I need to find the original gradient. So I need to start off by putting this into the form of y equals mx plus c so I can figure out what that gradient is. Once I have that gradient, I can go ahead and figure out what that parallel gradient is going to be. Once I have the parallel gradient, I will have almost the whole equation. I'll have y equals mx, but I need the plus c part. And to find that find that second point, I need to use the point that they've given me. Finally, that'll give me the plus c. Finally, all I need to do is put it into the form that they want. So when I have very clearly labeled out steps, I know exactly what I need to do, and it'll help me ensure that I've answered the questions fully. So following my little flowchart that I've created, the first step is to get it into the form of y equals mx plus c so I can figure out what the gradient is. So I'll just take the 3x over and the 5, which will make it a negative, so I can very clearly see that m in this case is equal to 3. Now, if we call that m1, because that's my original line, step 2 is to figure out what the second line's gradient is going to be, so m2. So I know that M2 will be equal to M1 if they're parallel, therefore M2 will be equal to 3. So what do I have so far? I have y equals 3x plus c. That's going to be my parallel line. Now, how do I find that plus c? I need to sub in a point. So the point I'm going to use is 2 and 3. I'm then going to sub that into the equation. So that'll be 3 equals 3 times 2 plus c. That'll be 3 equals 6 plus c. If I take that 6 over, I'll get negative 3. So the equation that I have is y equals 3x plus 3. And this is why it's really important to read your question carefully, because it looks like we have, sorry, that should be a minus 3. It looks like, we've got an answer, and we do, but it's not in the form that they've asked us to put it in. So step 4 is to then get everything over to one side. So that'll be y equals minus 3x plus 3 is equal to 0. And that's my final answer. We're going to do something very similar with part B. You might want to pause the video here and give it a shot yourself. Okay, so we want the equation in that particular form. It passes through the points negative 1 and 6. This time it's perpendicular, and it's perpendicular to that line over there. All right, so same thing. Perpendicular, we know that the relationship is negative 1 on the original is equal to the normal. So what that tells me is I need to find the original gradient. How do I do that? I can use the equation they've given me, but I need to put it in the form of y equals mx plus c. Once I have that, then I can sub in the m to find the normal gradient. Then I'll have an equation in the form of y equals nx plus c. To be able to find c, I need to use the point. And finally, I need to go ahead and put it into the form that is what they ask for. So let's follow it. Step 1, we're going to get it into the form of y equals mx plus c. So I'm going to take the 4x over and divide everything by 2. Also, just because we're used to putting the x first, I'm just going to rearrange it to put it in first. So negative 4 divided by 2 is going to be negative 2x, and then negative 10 divided by 2 is going to be negative 5. So that means the gradient that I'm looking at of the original is negative 2. Now for step 2, I know that the relationship between my original and the normal is this, negative 1 divided by the original. So my normal gradient is going to be 1/2. So now on to step 3 to be able to find the equation. So far I have y equals 1/2 x plus c. In order to find c, I need to substitute in a point. So that'll be 6 equals 1/2 times negative 1 plus c. That'll be negative 1/2 plus c. Take the half over. That'll be 13 on 2. So I'll get y equals 1/2 x plus 13 on 2. Once again, it's not in the right form, so I'm going to now rearrange it. Now, I can, of course, just take everything over to one side. So I'm going to start off by doing that. Let's change all the signs. But what you'll notice, and I mean, it's not wrong. If you left it like this, it's not wrong. But that's not really the way that we want to, it's not the nice way of presenting an equation. So the idea of taking everything over to one side is to allow us to get rid of fractions, to make it look pretty. So I can see that there are two things being divided by 2. So I'm going to multiply everything by 2 in order to get rid of those fractions. So you can see now it's the exact same thing, because when I multiply by one side, I have to do it to the other, but 0 times 2 is just 0. So it doesn't affect the other side, but what it does do is make the equation look a lot nicer. All right, on to example 2. So calculate correct to 1 decimal place the angle made with the positive direction of the x-axis by the line that passes through the points of negative 3 and negative 2 and 4 and 1. All right, key information. So first thing I'm going to highlight is correct to 1 decimal place, because I need to know how to give my answer. What we're looking for is the angle made with the positive direction of the x-axis. As soon as I see that, I'm thinking of the key formula m equals tan theta. It's really important, this formula. That's where the angle of the positive direction comes into play. So it has a relationship with the gradient. Now, do I have a gradient? I don't, but what I do have are 2 points. And I know that when I have 2 points, I can find the gradient. So I've made like a little roadmap. Now I can figure out the order. So in order for me to be able to use this, I need to first find my gradient. So first I'm going to do this. Then I'm going to substitute it in to be able to find the angle. And then once I've done that, I'm going to answer correct to 1 decimal place. All right. So let's go ahead and apply all of this. So step 1 is y2 minus y1, x2 minus x1. I'm just going to label it just this one time. From here onwards, hopefully you are feeling confident enough to do it yourselves. Okay, so that'll be 1 minus 2 on 4 minus 3. Okay, so that'll be 1 plus 2, which is 3, and then 4 plus 3, which is 7. So that is going to be my gradient. The second thing I'm going to do is I'm going to now equate it into the equation. So m equals tan theta. I know that m is 3, 7. That's equal to tan theta. And to get theta by itself, I'm going to take tan inverse of 3 on 7. Now what that's going to equal, go to this side. Once you put that into your calculator, you get 23.2 degrees. And just again, recognizing whether that's a positive or a negative. So that's a positive, which means it's got a straight angle, it's got a positive gradient, and it is on this side here. If it were negative, we would do 180 minus that angle to give us the angle that they're looking for. Okay, part B says determine the equation of the line that passes through the points 5, 2 at an angle of 45 degrees. So similar kind of information, we're using an angle. As soon as I see the word angle, I'm thinking of the equation m equals tan theta. And in this case, I actually know what theta is. It's 45 degrees, but we'll get to that in a second. We also have a point. All right, so what we know is that this angle is going to be able to give me m. And this point, whenever I have an extra point, helps me find any other unknowns. So in an equation, I have both m and c. And so that's the purpose of both of them. So I'm going to start off by finding the gradient, and then I'm going to substitute this point in to be able to find c. So starting off, we know that m equals tan theta. In this case, theta is 45 degrees, and tan of 45 is actually equal to 1. So my gradient in this case is just 1. So far what I have is y equals 1x plus c. And now in order to find c, all I have to do is substitute in the point. So that'll be 2 equals 5 plus c. Take the 5 over, you get negative 3. So your final equation is going to be y equals x minus 3. All right, the last little bit of this lesson today is about the midpoint and distance formula, which I'm sure you've worked heaps with today before. So we're just going to do a quick revision today. So the midpoint is essentially where I have 2 points and I want to find what the coordinate is in the middle. Easiest way to do it, you just add the two x values, find the average, add the y values, find the average. So that's the formula for the midpoint. The distance formula. So this is if I want to find the distance between 2 points. Well, the idea of this distance is that it kind of forms a right angle, right? And the difference between the x's is this side, the difference between the y's is this side. So to be able to find this, we can actually use Pythagoras' theorem. So if x2 minus x1 gives me a, and y2 minus y1 gives me b, then to be able to find this side, we would say c squared is equal to a squared plus b squared. Now that is where we get this formula from here. So the square root is because I'm just trying to get c by itself, so I would square root. And a is the x side, so that's x2 minus x1. And then b is the y side, that's y2 minus y1. So if you ever forget the distance formula, just think of Pythagoras and you can come up with the formula yourself. All right, let's go ahead and apply all of this information. So what it's asking you here is given you 2 points. They want us to calculate the midpoint and the distance. Midpoint, super straightforward. Add the two x values and average them. Add the two y values and average them. So negative 3 plus 4 is going to be positive 1, and then 5 minus 6 is going to be negative 1. And that's 1, 2. Then it asks you for the distance. It's just a matter of substituting in. So we'll do x2 minus x1 all squared. So that'll be 4 minus 3 squared plus y2 minus y1 squared. If that was a little bit confusing as to where I got the numbers from, please go ahead and label them. But as I said earlier, we want to try and get out of the habit of having to label and just be able to get straight into it. All right, and make sure you don't mix up your brackets like I just did. Now that'll give you 7 squared plus 11 squared. That'll be 49 plus 121, and that'll give you 100, root 170. We can't do much more than that. All right, so that's it for today. We've done quite a bit of revision. You've got exercise 2C, 2B, and 2D. Although we didn't really go over this, it's very much CAS for 2B, and then 2D is just application. So again, it's all questions that you've done. Thank you and see you later.